Learn Terraform with DoremonLabs.
Hello everyone, welcome back to DoremonLabs DevOps session. Today we are going to talk about Terraform. So, small brief about what I'm going to cover in this session. Then, first of all, I'm going to explain about infrastructure as a code, why it is needed for, what are the related tools that come in infrastructure as a code, and the concepts in infrastructure as a code. So, the next topic will be where does actually Terraform come in infrastructure as a code, and then we will start with our main topic, that is Terraform, and we will cover what is Terraform, what are the core concepts of Terraform, life cycle of Terraform, how does Terraform work, and finally we will have one hands-on session where we will be creating EC2 instance on AWS cloud platform using Terraform. So let's begin with infrastructure as a code. So the most common definition you will find on internet will be infrastructure as a code is the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. So it tells like we'll have automation to create our infrastructure. We won't have any manual operation in the case, and the data centers will be your private data centers or public clouds like AWS, GCP, Azure, and so on. So in simple words, I would like to define infrastructure as a code like it will manage your IT infrastructure using configuration files, and configuration files are nothing but your automation scripts. So if you see this diagram, you will see what kind of infrastructure code can do, right from network configuration, application configuration, storage configuration, security configuration, and overall cloud infrastructure. And in that you will find so many tools which will support infrastructure as a code concept, that is from Ansible, Terraform, Shape, and Puppet. Now the next point I would like to discuss about why there is need of infrastructure as a code. So there are three key problems which I have listed, and I feel because of these only we will need automation in our infrastructure so that our infrastructure will be consistent throughout and will have more efficiency over our infrastructure creation. So let's discuss about all these points. So historically, managing IT infrastructure was a manual process. People would physically put servers in place and configure them. Only after the machines were configured to correct settings required by that particular OS and particular application would those people deploy the application. And unsurprisingly, this manual process would often result in several problems. So the first problem is cost. You would have to hire many professionals to perform the necessary tasks at each step of the process, from network engineers to hardware maintenance technicians. All of those people need to be paid, obviously, but they also need to be managed. So that leads to more management overhead and adds more complexity to communication inside the organization. And what will be the result of this? Definitely, your so much of dollars will go away. And we didn't even mention building and maintaining our own data centers as well. We are still thinking like we will have public cloud and all the operations for that infrastructure creation, provision, and management will be a manual. Okay. Then the next problem is scalability and availability, right? So at the end, what is the main purpose of your work? That is the speed. So since you have manual configuration that is too slow, applications would often struggle with spikes in access, while the system administrators would be desperately trying to set up servers to manage the load, and this necessarily impacts your availability. So now you get this point, like let's suppose you have some application running on some 1,000 servers, okay, and as of sudden the load got increased and now your 1,000 servers are not capable to support that load. So definitely there will be a downtime. Maybe your server will go out of resources, and if your manual configuration in place, so definitely server administrators will try to add more servers to that particular cluster, but definitely it will take time as well to add those clusters, and definitely it will lead to unavailability as well. Maybe the chances your cluster may go down and your whole application will be down for several period of time. So this is the second problem scalability and availability comes in. Now, last problem will be the inconsistency. So we already discussed, like we will have several people to manage the infrastructure manually, right from network engineer to infrastructure technician engineers. So definitely each engineer will deploy configuration in a different manner. There will be discrepancies which we can't avoid if you have manual configuration activity. So definitely to mitigate all these problems, we should have infrastructure as a code. So where you will have configuration files, you will have automation in place to provision your infrastructure, to manage your infrastructure. On a runtime, you can scale your infrastructure and scale down as well with respect to load. So definitely we need an infrastructure as a code for our infrastructure overall management and provision. So infrastructure code is a concept which altogether have different tasks and has so many tools such as Ansible, Terraform, Puppet, Shape, CloudFormation, and so on. So now coming to the next point, what are the related tools that come in infrastructure as a code and concepts in infrastructure as a code? So infrastructure as a code is a concept which altogether have different tasks and has so many so many tools such as Ansible, Terraform, Puppet, Shape, CloudFormation, and so on. So definitely the question comes in your mind, that is, why do we have so many different tools? Can't we have just a single infrastructure as a code tool? Yeah, we won't have a single tool because no tool can do everything, and each one is great in a specific area. So let's take an example, like we will have Terraform. Definitely we are going to discuss where Terraform comes in infrastructure as a code. That will be used for provisioning your infrastructure. Then Ansible for configuration, you are configuring your infrastructure to deploy a particular application. So let's now discuss, like, what are those three phases where all these different tools placed. So three main task categories are like infrastructure provisioning and management, then configuration of provision infrastructure, and deployment of application. So the first phase, nothing but task, is infrastructure provisioning and managing that particular infrastructure, which includes spinning up your new servers, then your network configuration, then creating load balancer, and overall configuration at infrastructure level. Second comes configuration of already provisioned infrastructure. So there you will be install all your application required for that particular application to be deployed. Then managing those applications through some configuration, and preparing your infrastructure with all necessary stuff and dependency to deploy that particular application. Now you understand, like, let's take an example. Now you understand, like, with some example, like let's suppose we want to deploy some web application. So definitely we'll need some servers. So the first phase will be, we will be provisioning some servers through one of the IAC tool. Okay, then the next will be, now I want to deploy web application which is based upon Django framework from Python. So definitely I will need to install Python first over there, then Django framework over there, then only I can deploy my actual application on that particular server. So that comes in the second point. And the last point is actual deployment of application, where you will be actually deploying your application code on that particular server using Docker images or some app code. Okay, so now we are clear. There are three phases, like infrastructure provisioning and management, then configuration of infrastructure to deploy application, and actual deployment of application. So where does Terraform come in IAC? So Terraform comes in the first part of your IAC, that is, it is used for infrastructure provisioning and infrastructure management. And for your configuration of your infrastructure to deploy particular application and to deploy actual application, you will be having other configuration tools like Ansible, Shape, and Puppet in place. So now coming to our main topic, Terraform. So now we know what is IAC, what is used for, how it benefits to overall team, where Terraform comes in IAC, that is at infrastructure provisioning and infrastructure management part. So let's discuss about what is Terraform. So Terraform is an open source infrastructure as a code tool developed by HashiCorp. HashiCorp is one of the company who has developed this Terraform tool to provision and to manage all the infrastructure on different platforms like AWS, GCP, Azure, Alibaba, DigitalOcean, VMware, OpenStack, and so on. So it used to define and provision the complete infrastructure using an easy to learn declarative language. Okay. So now you understood. We will have some configuration files which will be used to create particular infrastructure. So same Terraform does. Terraform will have some configuration files which are written in the HashiCorp declarative language, that is HCL, and it will create and provision and manage our complete infrastructure on go. So it is the infrastructure provisioning tool where you can store your cloud infrastructure setup as pods. So now you understood cloud infrastructure setup as pods is nothing but your configuration files. Okay. So what it does, like it does orchestration, not just configuration management. Now you know what is orchestration. Like first of all, you will create a network, then you will create servers, then you will create storage for those servers, then you will create load balancers for those servers. So this is kind of orchestration can be done through Terraform. It supports multiple providers such as AWS, Azure, GCP, DigitalOcean, and many more. So as we are already emphasizing, like Terraform is capable to support almost all clouds, that is private and public clouds. Private are like OpenStack, then public AWS, Azure, GCP, DigitalOcean, Alibaba, and so on. And also it provides immutable infrastructure where configuration changes smoothly, right? So we already discussed, like there are thousands of servers were running. As of sudden load spikes in. So using this Terraform configuration, you can easily change your infrastructure configuration. Let's suppose right now you have T2 medium, like 2 core and 4 GB RAM machine with you, and now you need that machine to be changed to the upper configuration like 416. So Terraform gives you that feature to change the configuration on go, and that is also so smooth, like you don't need to worry about what will happen to infrastructure in backend and all. And as I said, it uses easy to understand language, that is HCL, that is HashiCorp configuration language, that is declarative language to write your configuration files. And you don't need to have a development background, because all those resources and configurations are already written. You just have to take out from their official documentation for that particular provider like AWS or Azure or GCP, and you just have to use that configuration files directly with your provider. So that is the one. Then also it support client only architecture, so no need to have additional configuration management on a server. So client only architecture means you will just have to install the Terraform client on your local machine. From that you will able to access your infrastructure, or you not just access, you will able to access, then you will able to provision, and you will able to manage that particular infrastructure from your particular server. So it is that easy to manage, provision your infrastructure. Okay. Now definitely at the end of this session we are going to do hands-on. You will able to see all these 4 concepts over there. So before that, I would like to explain you about all those 4 concepts in Terraform. So first is variables. So variables are also used as input variables. It is a key value pair used by Terraform models to allow customization. Okay, let's take an example, like I want to create one EC2 instance. So I will parameterize one of the variable in that EC2 creation process, that is the flavor of my EC2 instance. So for current I will pass t2.medium. In future, if I want to change that, I can easily pass another flavor, that is t3x large, using that variable. So this is the variables. Provider, we are already emphasizing, like Terraform supports so many cloud platforms like AWS, Azure, GCP and all. So Terraform have that provider configuration. It is the plugin to interact with APIs of service and access its related resources. So let's suppose take an example of AWS. In AWS we have so many services, right? So if you want to create EC2 instance only, we'll have to create first network using that VPC, then we'll have to create security group, then we'll have to create EBS volume, then we'll be creating EC2 instance. So these are the services So these are the APIs already available for that particular cloud. So provider will be act as a plugin to interact with those APIs of the services, and easily the Terraform can create the required resource on that particular cloud platform. The next point is module. So it is a folder with Terraform templates where all the configurations are defined. So we are already discussing, like we'll have security group, we'll have VPC, we'll have EC2. So this will be treated as a modules. So, and this will be the templates, like configuration files are nothing but Terraform templates. So this is the basic definition of module. State. So state is the main component, I would say. Like it consists of cached information about the infrastructure managed by Terraform and related configuration. So whenever you try to create infrastructure using Terraform, it will try to maintain all those states. Like right from first state will be like there is nothing is created by the Terraform on that particular cloud platform. So it will, once the infrastructure is created, it will store that state on its local machine where the client is installed, and it will be able to track that particular change is done by the Terraform. And if any, so it will track each and every resources with the state file. Resources, it refers to the block of one or more infrastructure objects. So as we saw the configuration files are nothing but the resources only. The resources are nothing but the declarative language made by HashiCorp. And let's suppose I want to create EC2, so there will be the EC2 resource in the Terraform that will be used, that configuration will be used to create the EC2 instance. If you want to create a virtual networks, that is virtual private cloud or virtual networks, so this will be other resource will be used to create a VPC in AWS or Azure. Data source, it is implemented by providers to return information on external objects to Terraform. Okay, so data source, like let's suppose I have created some EC2 machines on AWS, right? Not just on AWS, on any. I have created some VMs on some cloud platform, and now I want to use the IPs of those created VMs in my further resource. Let's suppose I want to add Route 53 entry for those resources. So data source will be the core concept will be used, where we will able to fetch the IPs of those EC2 resources which are created by Terraform on runtime, and that will be passed to further resources. Output values, like you want to return some values of your Terraform module. Same again, data source and output values act same. So once I create EC2 instance, I want that IP of that particular instance, I will put that in output values, and I will further use that output value in my next resource. So let's not just confuse between data source and output values. Output values run between the resources from one resource to another resource. Data source, even if that particular resource is not created by Terraform, still using the data source, Terraform will be able to fetch the information like S3 buckets or EC2 instances to use further. Plan. Now the next two are so much important because it will be a part of our next topic, that is Terraform Lifecycle. So plan, it is one of the stages where it determines what needed to be created, updated or destroyed to move from real or current state of the infrastructure to the desired state. Okay, now let's take example, like we are creating a fresh instance, right? So the current state is nothing is created. Okay, and we want to create instance, so this will be the desired state. Okay, so plan will be as the current state is nothing, and the desired state is like I want to create one EC2 instance. Okay, so all this determined by this plan core concept, where it checks what needed to be created, what needed to be updated, and what needed to be destroyed. If I want to destroy it, I can destroy it. Apply. So once you know the current state and desired state, and if you apply the changes, so it will move from your current to desired state. Like right now there is no instance created, the desired state is instance to be created. Once the apply source concept is applied, it will create that particular instance, that it will reach to the desired state. Okay, so it's a pictorial form. I would like to show you like how those core concepts are applied in a real world. So you will have Terraform state, we already discussed. We will have Terraform TFRs where we have variables. We have provider TF where we'll have configuration of on which cloud we want to provision infrastructure, and the Terraform instances TF, that will be the resources part. So whatever resources will be, right, like I want to create a EC2 instance, that will be treated as a resource for Terraform. That configuration for that particular resource will be written in the Terraform instances file. Okay, and you can see here like Terraform actually supports so many different cloud platforms like AWS, Azure, GCP, VMware, DigitalOcean, Alibaba, and OpenStack. So now let's move to our next topic, that is Terraform Lifecycle. So you can see Terraform Lifecycle consists of init, plan, apply, and destroy. Now you are already understood those core concepts. Like, so we know now Terraform init is nothing but it will initialize that particular configuration. Okay. Plan, like it will have a plan, like this is the current state and I want to reach to this desired state. Like right now there is no instance created, and in the desired state I will be creating that instance. So this is the plan state. Apply, you want to transit from current state to desired state, where we will have this apply lifecycle. And destroy, you will be destroying your infrastructure, whatever was planned in your state file. Okay, so these are the basic definitions I would like to tell you. Like Terraform init initialize the working directory which consists of all the configuration files. Terraform plan is used to create an execution plan to reach the desired state of the infrastructure. Changes in the configuration files are done in order to achieve the desired state. Terraform apply then makes the changes in the infrastructure as defined in the plan, and the infrastructure comes to the desired state. And Terraform destroy is used to delete all the old infrastructure resources which are marked tainted after the apply phase. Okay, so now you understood, like Terraform init initialize your working directory where all your configuration files are placed. Configuration files are nothing but your resources configuration. Terraform plan is used to create execution plan to reach to the desired state from your current state. Terraform apply uses that execution plan to reach to that particular desired state. And Terraform destroys, once you reach to that desired state and you want to destroy that particular infrastructure, you will apply Terraform destroy. So this is the life cycle of Terraform. Now next topic is like how Terraform work. Okay, so Terraform has two main components that make up its architecture. So first is Terraform core and second is provider. So we already discussing about all these components, right? So the Terraform core will have two input sources. First will be your configuration templates, configuration files, which includes your resources code, which is written in the HCL, that is Hashicorp declarative language. And then the state file will be the second input, the current state of your infrastructure and what will be your desired state of the infrastructure. That we give these two sources as the input to Terraform core. Providers will be the second component. The second component of the architecture are the providers for specific technologies. This could be cloud providers like AWS, Azure, GCP, or other infrastructure as a service platform. So now you understood, these are the two components we will have if you want to work with Terraform. That is Terraform core, in which we'll have two sources, input sources. First will be the configuration file and second will be the state file. And the second component for the Terraform work will be the provider. Okay, so let's have this pictorial form. Now you will briefly understand like how the Terraform works. Like we have Terraform configuration files with .tf extension. We'll have tf state file. When we will do plan, it will create a state file which will have execution plan to reach desired state from your current state. And you will have providers.tf file. Here we will mention like on which provider you want to create the infrastructure. Okay, so now you know what is Terraform, what is IAC, what are the core concepts of Terraform, what is the life cycle of Terraform, and how the Terraform works. So this is the diagram I wanted to show you, like what was before Terraform, like what was before infrastructure as a code, and when we had infrastructure as a code tools, how the process got smoothened. Like before Terraform, like before ISCC, infrastructure as a code tool, application team used to request some infrastructure to IT team. Then IT team manually used to create that infrastructure manually, which used to take a lot of time. Like definitely it will take a lot of time. Like you will talk with your infrastructure providers, you will list all of those infrastructure requirements. Then they will create it, and then IT team will pass it to application team for deployment. And once we and the day we and once we had IAC in place, like infrastructure as a code, so the process was too much smooth. Like we don't need to have a big team of IT team. We will have application team in which we will have DevOps members. So DevOps members will be writing TF templates to create what exactly application team wants, like how many EC2 resources they want, how many load balancers they want, and they will have TF client in place so that they will create infrastructure on go with those configuration files on required cloud platform like AWS, Azure, GCP, and so on. So now we are coming to our final topic of our Terraform discussion, that is hands-on session on our Terraform. So okay, so to let's so as we discussed, like as we know, Terraform supports so many clouds like AWS, Azure, GCP, Alibaba, OpenStack, and so on. This hands-on is related to AWS cloud platform, but there is no that much difference with other clouds. The main structure, the main framework for any Terraform code for any cloud is the same. Just the resources configuration will be changed, not up to not 100% will be changed, up to some extent that changes will be there for that particular cloud. And Terraform, and I would suggest you guys to use Terraform official documentation only to write this code, like write this configuration for your any cloud like Azure, GCP, AWS, and so on. So prerequisite is, for AWS provider, you will have to be install AWS CLI first, and you should have terminal based access to your AWS cloud, in which it will have all resources access, the necessary resources access, whatever they want to create. Like for if you want to create EC2 machine on AWS cloud using Terraform, that your AWS CLI should have that access. So AWS CLI should be installed. Okay. And this is configured with your access scan secret key. Next is Terraform client should be installed. So it is very easy to install. Let me show you steps directly. Actually, I have already installed. I will just show you the steps. Just a minute, guys. I'm finding out all those steps. So first you will be installing yum utils, then I'm just copy and pasting it from official documentation of Terraform only. And finally, I will be installing Terraform. Okay, so you can see the Terraform is already installed, so that's why it is showing nothing to do. Let me show you Terraform command. So you can see our Terraform is installed. We have configured our AWS CLI as well, right? Okay. Let me paste you here the URL for the Terraform installation CLI as well. So you can get this URL from here. This is the URL where I'm taking all these commands to install Terraform on my Linux machine. So now let's come back to our Terraform demo. Now let's open the first file, provider.tf. So we already discussed, like here we'll be mentioning what provider we are going to use, like we are going to use the AWS. So this is the required provider definition. This is also you will get from Terraform only. You don't need to write it somewhere or to memorize for your further use. You will get this information from your official Terraform documentation. Just search for create EC2 instance Terraform provider AWS. You will get this patch of code from that document over the internet. So this is the provider. Here we are mentioning like this AWS will be used to create instances. We have already configured our AWS scan secret key or AWS CLI. Here we are just mentioning on in which region we will be creating our instance. So I'm going to create instance in AP South 1 region, that is in Mumbai, India region. So this is the one. This is the one of the core concepts we discussed in our previous slides. The next is variables.tf. So this is the another core concept we discussed, like here will be parameterize our EC2 instance. Now, like I said, like right now I created instance with T2 micro, but in future I want to change it to some T2.mediums. I can easily do that. I haven't hard coded my resource configuration directly, so I can pass it on runtime. So these are the variables. In this fashion we define it. Variables.tf. Okay. Next is main.tf. Now you can see here, like we were talking about resource, like so this is the resource, nothing but AWS. Like if you want to create security group, so these resources will be used. Okay. And here I have mentioned all my security group policies, like what ingress to be open, what egress to be open. Then you can check for another resource like AWS instance. So this resource is used to create your actual EC2 instance, where we are passing all those variables from that variables.tf file, like AMI value is there, then instance type is there, subnet ID, associate public IP address, like whether I want to attach public IP or not. So I'm passing that flag here. Then key name, like what key will be used. So we have already created key on our AWS and we are using that key only. So let me show you that variable.tf file again. So here you can see the key name is Terraform demo, which is already created in my AWS account. Then T2.micro for instance type AMI. This is the Amazon Linux AMI, resides in AP South 1 region. This is the default VPC ID. Then this is default subnet created in this VPC that I am going to use. And the security group name will be this. And okay, so coming back to main. So now you understood like what are the variables, what are the resources. You don't need to have a developer background. This code is readily available on Terraform official documentation. I just copied it from there and just changed with respect to my requirements. Like here I am passing security group which is being created over here. Now you can see like I am passing this resource value from here to here. Then I'm attaching root block device, like I want 50 GB root volume, which will have volume type GP3 over here, and the tags will be this name, environment, OS, and manage. So my instance name will be server 01 name, environment will be dev, OS will be Amazon Linux, and managed by IAC, that is infrastructure as a code. Okay. we were talking about this output core concept. So here I'm trying to get the EC2 instance IP that I can use in further resources. So at the end of this hands-on session, you will able to see the IP of our EC2 instance, which was created by the Terraform because of this output configuration only. Okay, so now you understood. Okay, so let's begin with our Terraform lifecycle. So first you will do Terraform init. So what it will do, I already done now. Let me just delete. I do Terraform init. So you can see here like it is initializing the provider first. Like I wanted to use a HashiCorp of AWS provider, so it install the configuration for initialize the configuration for this provider. Then okay, so what it exactly does, like it the resources which we have used, that will be configured using this HashiCorp of AWS provider only. So this is how it initialize our configuration files. So once the configuration files initialize, we'll do the next stage of our Terraform lifecycle, that is plan. So here you will able to see the plan, right? This is nothing but the plan. What it tells, like what is your current state, there is nothing is created, right? What will be desired set, there will be the two resources will be added. One is security group and another is EC2 instance. Okay, so this is the plan, and this plan will be used further to reach to your desired state using that Terraform apply stage of. Okay, so if I do Terraform apply, it will use this state. It always gives you prompt, right? You can avoid this prompt, but as a standard practice we recommend to have this prompt. So by mistake you won't apply anything which is not required. So once you enter yes, it will start using that plan to reach to the desired state from current state. The current state is 0 resources created, and the desired state would be 2 resources added, which are configured in your main.tf file. Is still creating. See, the resources are created and we have got our IP as well, that is 3.1.10.137 is created here. So if I try to access this IP, definitely I will be able to do it. I am able to access that particular instance. This is true, like Terraform able to created our required instance on AWS cloud platform. Okay, now you can see like apply completed, 2 resources added, like it reached to its desired state. Now the current state is like the 2 resources are added using this Terraform, and also the state file also is created over here. So for further changes, it will use this tf.state file only. Just a suggestion, you will have to keep this file safe whenever you want to perform some operation on your infrastructure using Terraform, which you have created using Terraform only. So this file to be saved somewhere securely, because this file will be used to track the current state of your infrastructure was created by Terraform. If you delete it, it will won't able to find this infrastructure and you won't able to delete your infrastructure. Now let's see, now I'm trying to destroy my infrastructure, so it will be use this Terraform state file only to track the current state of our infrastructure, that is 2 resources are added. So you can see here like changes to output, 2 to destroy. Using that state file only, it was able to see like this security group is one of the resource and another is EC2 instance resource that we have to destroy. If I click on yes, see it has started destroying that instance. You can see here as well like our instance went into shutdown mode. Now no longer we will able to access this particular IP. So we conclude that we check for our Terraform lifecycle, that is from Terraform init, Terraform plan, Terraform apply, Terraform destroy. You can see this example. Yeah, that's it from my side. Let me know your doubts in comments. I will definitely like to solve those doubts. Thank you.
If you like this video and want to learn about more DevOps tools, then subscribe DoremonLabs. DoremonLabs, a perfect DevOps partner.